Discuss about the identifications of cation by flame test. This is a clean, dried platinum wire, concentrated HCl, and the salt under investigation. First, we'll discuss about identifications of sodium by the flame test. In this case, we took a sodium chloride salt. First of all, you have to make a paste of this salt with a concentrated HCl. And we have to inject this one with to the non-luminous flame, the constant flame. Clearly you will observe that a golden yellow flame, this is the characteristics flame of sodium. Right, golden yellow flame is the characteristics of sodium, and this is the persistent flame. In the next experiment, we'll discuss about another salt. This is the calcium salt, and it will show the non-persistent brick red coloration. Non-persistent brick red coloration. This is the concentrated HCl again. To make a paste, but for the sake of simplicity, we are using simply just a salt with our HCl. It will form non-persistent brick red. Look at that, the non-persistent brick red. The coloration initially it was white, yellow in color, but afterwards the non-persistent brick red colorations. Is the brick red colorations observed. The chlorides of metals are generally volatile in nature. On heating, it will directly form a cation. On further heating, cations will go to the higher allowed path, the Bohr's orbit. When it jumps back to its original positions, a characteristic color is observed in the visible region. By this way, you can observe. Look at this. This is the brick red, non-persistent brick red colorations for the calcium. In the next experiment, we'll discuss about another salt, the characteristic taste for that potassium. In this case, we took another salt of potassium, concentrated potassium iodide. We took again a concentrated HCl, a lilac flame, a beautiful lilac flame will be observed. Basically, you have to prepare a paste. For the sake of simplicity, we are just simply injecting the salt. The bright lilac flame is observed. And these colorations is observed only in the case of oxidizing flame. Lilac colorations observed. This is the confirmatory test for potassium. Next, we'll discuss about confirmatory test for copper by the flame test. It will show that bluish green, a nice bluish green, or rather you can say that peacock green coloration in that non-luminous flame of a Bunsen burner. The peacock green or the bluish green colorations observed for the case of copper. For the case of copper, because since it is in the hydrated state, make it anhydrous, you have to use more amount of heat and for a longer period. Initially it will form a cupric chloride, then electrons will jump, and finally when it jumps back it will form a bluish green or the peacock green coloration. Sometimes the anion borate also interfere this test, but this is a simple green coloration, not that peacock green coloration. This is actually peacock green colorations of the copper. To move that electrons from its higher orbit, in the case of copper, since it is hydrated, it will take a longer period. Finally, we will discuss about strontium. In this case, you will observe a crimson red, a bright, persistent crimson red colorations you will observe. This persistent, not like calcium. Crimson red coloration. Calcium, strontium, barium, radium, these are in the group 2 and they have 2 electrons in their outermost shells. They are highly stable in nature, so to remove one electrons from the stable state to the higher one, it will take a longer period. So this is the crimson red colorations of the strontium. This is the crimson red coloration for strontium. And last, again we will discuss about characteristics test and the conformity test for barium plus 2. This is again the group 2 elements. This is the barium. The group 2 elements, beryllium and the magnesium, will not show any colorations in the flame test due to the smaller size. It will show that non-persistent apple green coloration. Apple green colorations for the barium. So in this way we can identify that the cations that are present in organic salt.